Now let's see radioactive wastes. Now many medical procedures involve the use of unstable isotopes of certain elements, such as cobalt-60, and these undergo radioactive decay. Now what is radioactive decay? Radioactive decay means that when you have the unstable nucleus of the radioactive isotope that emits particles but also emits radiations. Some of these radiations can cause ionization. Ionization is when you are going to release electrons, right? And it can damage living cells. These are called ionizing radiations. In high doses, ionizing radiation causes cellular and genetic damage. Low doses of radiation increase mutation and cause risks of cancer, birth defects, and reproductive diseases. So this is a graph that shows you radioactive decay. So we have the term half-life that is here. So half-life is the amount of time that it takes for the element to decrease to half its initial value. So initially it was 100, time that it takes to decrease to 50. So this would be the half-life, also called T-half. So again, half-life. So from 50 it's going to go to 25. From 25 it's going to go to 12.5 and so on. So that's half-life. Now, during medical procedures, ionizing radiations come in contact with many materials that themselves will become radioactive. For example, needles. And such materials and leftover radioactive isotopes produce nuclear waste. And these nuclear waste need to be disposed properly. There's 3 types of radioactive waste: high-level, intermediate, and low-level wastes. High-level waste will give out large amounts of ionizing radiations for a long time. Low-level waste will give off small amounts of ionizing radiations for a short time. So this is a table that summarizes low-level, intermediate, and high-level wastes. So high-level waste, you have, for example, unused nuclear fuel, products of nuclear fission. Now, normally in medicine, radioactive substances are used to diagnose and sometimes to treat diseases such as cancer. So, for example, if you want to have medical imaging of bones or the presence, or to detect the presence of tumors to find risk of heart attack, normally patients are given radioactive isotopes that they ingest or that they are injected with. Now, during the process, any object that comes in contact with these radioactive isotopes become radioactive. This includes syringes, disposable gloves, bedding, or any absorbent material such as cotton swabs. So all these will become radioactive, and these substances result in radioactive waste. Now, low-level waste include gowns, protective clothing, shoe covers, right? So as I was mentioning, and these are disposed into shielded containers until the isotopes have decayed and then disposed as non-radioactive waste when the radiation level has dropped to a safe level. Now, radiation levels are measured using an instrument called a Geiger counter, and it measures the radiation emitted by objects. Intermediate level waste include radioactive sources such as cobalt-60, cesium-137. These are stored in shielded containers in underground repositories. Now, normally in medicine, these are the 2 main waste that are going to be produced. High-level waste is not very common. But high-level waste, these need to be stored in steel cylinders covered in concrete and buried deep underground. Now, radioactive materials discarded together with antibiotic waste can increase mutation rate in bacteria and accelerate the development of drug-resistant strains. For example, a person becoming infected from an injury by contaminated hypodermic needles that introduce the bacteria directly into the bloodstream. Nuclear medicine can generate waste that contain gamma radiations. There's 3 types of radiation: alpha, beta, and gamma radiations. Now, gamma radiations, they can cause cellular damage. They can specifically damage the DNA. And when the DNA is damaged, it results in uncontrolled cell growth or cell death. And this is what results into cancer. Normally, if a person is exposed to low levels of these radiations, the cell damage is undetectable and the cell is able to repair the damage. However, when there is exposure to high levels of gamma radiation for a long period of time, it can result to radiation sickness. So, for example, if someone drinks water contaminated with these nuclear waste, or eating fruits or vegetables that have grown in contaminated water, or just being close to a source of radioactive isotopes.